Hi, everyone. My name is Tracey Dudding, and you will see a bunch of lectures that I have tried to make extremely short that I believe are a good basis and understanding you should have of statistic concepts. So, the first one we will get started on is statistical studies. Statistical studies is formed essentially of six steps. We have a general topic that you're going to be interested in. We will formulate that general topic into a very formal research question. Then we need to collect data and assess that data to answer the research question with analysis, and you'll get your results from your analysis, and which will be the conclusion, but you need to interpret that or put it in a form that almost anyone can understand. Let's get started on the first step. The first step is a topic of interest. This is a very general statement that you'll make. I'm interested in healthcare. What about healthcare are you interested in? Are you interested in blood inventory? Good. Okay, well, now that's when we take the next step and form the more generic, more formal research question. The research question can be complicated sometimes to form because there's very particular amount of steps that you should take. Here in this lecture, we're going to be very general on what to do, but essentially it's taking your general ideas and translating them into a question that can be answered with the data that you collect. So let's go over what makes for a good research question and how do we actually do it. So, a good research question is a clear, focused statement with the ability to guide and center your entire research. So, I want you to think of just some general topics real quick and then try to form them into a research question. And then I'll give you a few examples that I have and what makes them good or bad research questions. So, let's take a few minutes and do that. Now that you have had some time to think about some research questions yourself, let me give you a few examples and explain why they're bad or good. The first example, why did the chicken cross the road? It's a good question. It's a nice topic, but it's not a good research question. And why? That's because it's too broad. What chicken are we talking about? What road are we talking about? You have no idea. So you need to be a more direct. And this is a very trivial example, but we'll keep going. So our second example, how many chickens crossed Broad Street in Durham, North Carolina on February 6, 2014? Okay, we are more distinct here. We talk about a street. We're asking how many chickens do it on a particular day, actually. But can we answer this with any kind of data? It kind of doesn't leave much room for analysis. It's like, okay, I can look this up somewhere. Like, I'll go and look up Broad Street in Durham, February 6, 2014. Maybe there's even some video, but it's simple. I can just count how many chickens, and that's the end of it. That's not really a research question that can go on and have some meaningful results. The third example, what are some of the environmental factors that occurred in Radford, Virginia between January and February of 2021 that would cause chickens to cross Broad Street? Now, this question can lead to a lot of interesting facts. We could possibly identify factors that were significant, and to what degree maybe the results will be beneficial. But that's a better research question. Do you see how we kind of took different steps and how to form that? We started really broad, and we got a little more specific, and then we really zero in on what we want to answer. That brings us to how do we actually do this? A quick checklist for you I've gathered that may help. We want to go over these things anytime we form a research question. That is the question a new spin or an old spin on a different idea, or is it trying to solve a problem? And the way the research question is stated, figuring out this question will help in you forming it in a particular way. You also want to gather some facts about it. Is it already answered that, there's no point in you actually doing a research question if it's already answered, or you find facts about it that you didn't know and maybe you need to explore it some more. You also want to match any kind of facts with theory if it is available. You also want to evaluate or compare theories or models or hypotheses that you may have with pre-existing ones. And then, of course, we talked about, is it too broad or narrow, your research question? If it is too broad, we need to zero in and narrow it, but not too narrow, because if we get too narrow, then it's just, you won't have good results. Oh, yes. And will your results be repeatable and comparable to existing models? The biggest thing is it repeatable? In a statistical study where you're doing analysis, your results need to be repeatable, especially in clinical trials. You don't want to be given a drug where, okay, it did good for this set of group of people, but for the remaining 3 groups of people, it did bad, and then it did good, and then it did bad. That's seems by chance. Then at that point, you need to have consistent, repeatable results. On to the third step, data collection. Now, this step is in my sense, the very first step to actually answering your research question. You can't move on without the data. And also, it'll probably come in a bunch of different formats and from different places. It can be in a CSV file, it can be in a JSON file or XML file. It can also come from multiple different databases. You could have structured data in a relational database, or you could have unstructured data. It's a bunch of different things you'll have to think about in data collection. And if you're pulling from multiple sources, you got to think about data integration at that point. However, for statistics, we're hoping that the data engineer will do this for you, but this is still something you need to be conscious about and consider when you have your research question, is getting the data. The next step is the data quality. Now, a lot of times your data engineer might just give you the data and tell you to fix it. Good data engineers will work with you and try to solve that problem. Let's take a quick look at some data here. It's in the bottom right on the slide, so if you want to follow along with the slide, you can. However, I'm going to go ahead and pull this up in an Excel file. So here we see last names and first names with gender, age, phone number, and date of birth. Very simple example here, but let's take a look at this column. Here we see gender, but we see a bunch of different values for gender. We have male capitalized and spelled out. We have it lowercase and spelled out, but then we also have M here. And then what is F and A and T? What are those values? We aren't quite sure. But you see all those different formats. We really need to standardize that to either a capital M and F, possibly, if we can. And then let's take a look at this column as well. We see the same thing happen here with phone number. We have phone number with the first 3 digits in parentheses. We have no parentheses at all and everything together. We also have dashes. We need to standardize that to a very specific format. And then if we take a look at the rows here, this row, and this, well, these 2 rows right here, their age is in the hundreds, 350 and 890. Nobody can be that age. I mean, maybe someone wished they could be, maybe not, who knows? But obviously something went wrong. That's when we need to go and look at the date of birth and calculate it, their age ourselves if we can, if it is acceptable to do that, if you know it's the current data extract that you've done. The other 2 rows So let's take a look at this number and this number, but with these dates. So assuming I just did this data extract itself, and this is their date of birth, we see their age is not right at all. And it could be a bunch of different reasons of why, but if you did this extract today, you can go ahead and recalculate that age. Otherwise, you kind of, you don't want to lump, if it's way off, you don't want to lump them into a group that is wrong, or assess with data analysis for individual age. But if you are lumping it in a grouping, so say ages 20 to 35 or something like that, then it leaves a little bit of room for that error that could be in the data. Okay, so these are just some quick examples of assessing data quality and how you can do it and fix it. Now, if you are pulling data from a database, hopefully there are constraints on that and you won't run into it as often, hopefully. But if it's survey data, then I guarantee you're going to see it. The fifth step is data analysis. And this step is where we're just taking our statistical methods or process and applying the data that we've collected to generate the answers to get to our question. There's a bunch of different types of analysis you can do, such as descriptive, diagnostic, predictive, and prescriptive. We won't go into those in this lecture, but at the end of these slides that you should have, there are resources to go and look into that a little more if you don't know anything about those. The last step, and one of the most important steps, I believe, is your conclusion and how you communicate the results that you have from your analysis to another individual, another party, because they're most likely not going to be a statistician and understand anything of what you say. So you need to communicate those results so anyone, almost anyone, can understand, or whoever your particular audience is. It's the same as writing a paper. If you write a paper for a conference, you're writing that paper for a committee to review it. If you're writing a paper or a short story for kids, then you would expect someone who is 8 or 9 or even younger to understand it if they can read. Let's take a look at a good example of this. They actually have done a predictive model. And how do I know that? It's because of this line right here that says forecast. Here they've taken historic data and they've projected that fossil or renewable fuels in the coming years will increase, right? And they're also projecting that fossil fuels will decrease. Such a simple graph, but yet it's communicating it's the results that they found. Okay, I expect one to increase and I expect another to decrease. That is what I mean. You don't want to just give numbers to an individual and expect them to understand. If you know anything about p-values, okay, well, I have a p-value of 0.0001, and I found that it was statistically significant that renewable energy is going to increase from 2020, I believe, to 2031. So that means nothing to somebody. I mean, it means something, but here we see actually we can even make a comparative between these two lines. Okay, well, we might say that in 2023 we don't see a huge big difference in them, but by 2031 there is a huge difference. That's another thing that they're communicating here that they might have not gotten across by just giving those simple numbers. So that is why it is so important to communicate your results effectively. So let's review really quickly. The goal of this lecture is to understand all 6 steps of a statistical study, and that includes identifying what you're interested in and then forming a research question based on that area of interest. And then you'll have to collect the data, and you have to understand that a data engineer is going to be helping you do this, but you also need to understand what they're doing for you. And then, of course, data quality, that can fall in your hands or the data engineer's hands, but you always have to assess your data quality before doing any kind of data analysis, because if you don't, your results may mean absolutely nothing. And of course, finally, you take your results from your analysis and you want to present them in a manner that almost anyone can understand.